Hello 108 students, Mr. McHugh back here with you on section 4.1. We're going to wrap this up on page 4, and this objective is called special systems, but let's just let's work some problems here, how you might encounter them here. And let's keep in mind that we had options of lines, 2 lines that intersect, 2 lines that were parallel and never touched, and 2 lines that were stacked on top of each other. Okay, we've been working hard on substitution and elimination, and so you're given an example of a problem here, and let's look at example 9 here in my notes. X plus 3y equals 4. Second equation, or the B equation, is negative 2x minus 6y equals 3. And you're like, okay, need to eliminate one of the variables, and oh, I don't know, I'm going to pick on the x variable, and you might maybe pick on the y, but let's just pick on the x, and I would do this one for elimination because it's got that coefficient of 1. That's always a little easier. What can I multiply equation A by to get a positive 2? Because if I had a positive 2 added to a negative 2, I would come up with a 0, so that's my goal. So I'm going to take the original equation, I'm going to put brackets around it and multiply it by that positive 2. Okay, that's all I got to do here, because I'm going to get that 2 times x is 2x, 2 times 3y is 6y, 2 times 4 is 8, and I know my x column is going to be eliminated with a 2 plus a negative 2. And again, I didn't show it here, but usually in class I put a plus sign that remind me with a parenthesis. This is just my notation. I am adding the columns. I like to add the columns. You can subtract them, but I like to get the signs opposite and then add them so I don't make any mistakes, because if you don't do this right, this is where you'll make mistakes and go bananas. Okay, 2 plus negative 2 is 0. I'm like, okay, mission accomplished. And then watch this. 6 plus negative 6. I'm like, ruh-roh. What happened to the y variable? It vanished on you. This is when you know you've got one of these special systems going on. 8 plus 3 is 11, and I end up with 0 equals 11, and that is a false statement. That is not true. Okay, here's where you stop. You might go back and double check your work to make sure you didn't make a mistake somewhere and you're like, you did everything perfect. When you end up with this false statement, that is implying to you that there is no solutions. Okay, that kind of makes sense because you have no variable, and the lines were parallel to each other. Now that makes sense. 2 lines are parallel, they never intersect. There's never an ordered pair that is between them, because they will never touch. Okay, so that's one of your special systems here. If you get a false statement, no solution, null set. Sorry, that's not a very good null set. Null set, and the lines were parallel if they ask you to describe them. Okay, you're cruising, you're looking good here. Example 8 comes cruising along, and you go, okay, equation A, 2x minus y equals 3. Equation B, 6x minus 3y equals 9. And you decide to, maybe this time you pick on the y. Again, I like that when the coefficient is a 1 here. And I see a negative 3y, so if I would multiply by a negative 3, negative times a negative would make a positive 3y. I would add up the columns and eliminate. Okay, so there's my goal. There's my strategy. I put my brackets around equation A. I multiply by that negative 3, because a negative times a negative will produce a positive 3y. A negative times 2 is negative 2, 6. Negative 3 times 3 is negative 9. That's the rewrite of equation A. I leave equation B alone. Notice here I did put the plus sign in my parentheses to tell me to add the columns. I'm like, whoa, negative 6 plus 6 is 0. And I wasn't expecting that. I was expecting this. And then I get negative 9 plus 9. I got 3 zeros all adding up to 0 equals 0. Is that a true statement? Yes. Oops, sorry. Yes. Therefore, you have many solutions, and the lines overlap each other. That's because every ordered pair, every dot on there represented by x comma y, will satisfy both those equations. I could have you guys work until the cows come home. I could tell you 3 comma 2. I could tell you 9 comma 5, and whatever values I give you, you put them in there, they would work out. Okay, so that's just the idea to see that when your variables drop out, there's special cases. you get a true statement, the lines overlap each other, many solutions. If you get a false statement, they're parallel and no solutions. Okay, hey, Mr. McHugh here. I am going to wrap up section 4.1, page 4. It's done. It's a wrap. We are going to skip 4.2, and I will see you for the beginning of 4.3. Okay, take care. Bye-bye.